Welcome back to Digital Trends Live. Thank you for joining us. As I always say, hit that subscribe button. That way you get the notifications when we do go live, because we get to have some amazing discussions here and you can be part of it. And I'm excited right now to talk about this. This is certainly something of interest to me, but I want to introduce myself. I'm Greg Nibbler, and joined by Othniel Mbamalu, who is the founder and CEO of Advanced Rockets Corporation. Hello.
Hi.
How you doing?
I'm doing good.
We have had Othniel on the show before via Zoom, but now he's here in studio with us, and I probably said it before, but what an amazing name for a company, number one.
Thanks.
A great name. But let's give everybody just kind of, before we talk about some of the specific things that you're doing in the overall field, can we give everybody just a little bit of a background on your company again?
Sure, absolutely. So we started Advanced Rockets about 2 years ago. The primary objective was to commercialize our patented and patent-pending hypersonic flight technologies, and most of those technologies are in the air-breathing space. And so the applications for this range from a low-cost access to space is one of the possibilities we're looking at, and then hypersonic weapon systems, and then civil aviation, high-speed civil aviation applications. And so the application for the technologies we're working on are extremely vast, and we are super excited to work with industry and share some of that information.
Yeah, I mean, it's a really incredible field and time right now, I feel like, because there's a lot of companies that are working on this, and we're taking a look right there at one of your, I'm assuming one of the prototypes or one of the ideas of how that could be utilized.
Yeah.
I know I want to talk about the entire field, but let's talk about something specific with you, and you do have a new partnership that's going on too. Can we get into that a little bit?
Sure. Aerospace is an extremely complex field, and most of the work that we do in partnership with other companies. Almost every other aerospace company out there has a form of partnership with other aerospace companies. And so we formed a partnership. We've been in partnership with Jacobs Engineering, and the work we do with them is as it relates to NASA. And so they serve as a liaison between us and NASA. And so we do not have access, we do not have hypersonic, supersonic wind tunnels. And so NASA has access, NASA has some of those facilities, and we have access to that. And so the partnership with Jacobs is extremely critical to development goals for the technologies we're working on.
So, and that's great. I feel like there's a lot of partnerships that are going on within this field, because there are a lot of people that are entering into it. But to have all the capabilities with one company, I feel like that would probably be pretty difficult, because, like you said, access to these hypersonic wind tunnels and things like that. Certainly, the partnerships help out with that.
Correct.
Talking about the different applications, let's walk through some of those things of what you're looking at. You mentioned hypersonic travel. Mm-hmm. How would that actually work? What would that look like for just overall?
So a good way to visualize what we have been able to do at Advanced Rockets is there's a concept known as MDO, so multidisciplinary optimization.
Okay.
So hypersonic vehicles are highly blended vehicles. And so every single system, every single part is optimized to work with every other part there. So say, for instance, if I were to design what would be a conventional design approach, if I were to design an aircraft, a commercial airliner like a 737 or whatever it is, I could design the wing and the fuselage and the tail section with a fair degree of flexibility, and then I could put all that stuff together. But when you design hypersonic vehicles, especially air-breathing systems, every single system is highly integrated because they have to work with each other. And so there's about 100 factors that we could optimize for, and we can only optimize for 20 of them right now. So about 20% of the total of all the different factors. So length, width, angles, and all of that stuff as relates to the vehicle. What we've been able to do is we've been able to take all those different factors that you could optimize for, plug it into the simulation, and then you get basically what is essentially peaks and valleys. And the peaks are basically performance, and the valleys are basically what the cost would be. And so you basically select for what would be the optimal cost to performance ratio. What we've been able to do is we've plugged in all the different concepts and ideas for what a scramjet or a hypersonic vehicle system might be, both in weapon systems, both as might be used in launch vehicles. And we've been able to achieve a better cost to performance ratio than any of the systems we've been able to look at by a factor of 20 in some instances. And so that's very significant. That is looking at reuse for launch vehicles, say, at about 400 reuses, where you have 10 in some instances or a little more. you're looking at 400. You're looking at high utilization. So the capacity or capability for a launch vehicle to go to space, come back, and within a couple of hours, we're able to turn that vehicle around and send it back up. So all of those factors tied into each other are some of the benefits and promises that our technology offers. It's not just an application in launch vehicles, it's applications in hypersonics weapon systems, it's applications in high-speed civil aviation. So,
Which I feel like factors into that multifunctional aspect that you were just talking about, and the reusability, which is so key to keeping those costs down. I would imagine that's a big factor when it comes into that, when you're talking about those peaks and valleys, the reusability factor.
So reusability is a critical factor, but it's actually a small factor in terms of determining the cost of access to space. There's been a lot of talk about that, especially with the work SpaceX is doing. High utilization and continuous intact abort capability, which is basically the ability for a vehicle, not just contingencies, to be returned back to the launch site. If you were to detect an in-flight anomaly in flight, usually we would basically just blow up the rocket.
Right.
And the ability for a vehicle to do that is consequent upon some of the efficiencies with which our system can operate. So a quick example would be the efficiency. We measure efficiency in rocketry in specific impulses. So the Merlin for the SpaceX or any other rocket, quite frankly, has a maximum ISP of 450 thereabout.
Okay.
We are able to operate at ISPs through the entire mission range. We're able to operate at ISPs of close to 1,500 and above. And so you have a factor of 3 to 4 times greater efficiency. What that means is you carry less fuel. We can carry more systems to keep the crew and the vehicle safe and return it in case we had an in-flight anomaly. So it's orders of magnitude in some sense, in one sense of it, better than anything that's been developed or worked on today.
I think that's an interesting way to look at it. I didn't, of course, we're not all rocket engineers, so I didn't actually factor that part into it as far as that. You always think about the reusability factor. So looking at it from that standpoint, and let's go back to the aviation side. And I know there's a lot of different things that this technology can be applied to, but when it comes to hypersonic travel, like say just commercial travel, how far away are we from something like that, and what would that actually look like for an average person?
So a good answer usually would be we look at what we did in the Apollo era, right? So we had an objective, we wanted to achieve something, and we did it. And so I think the biggest limitation we have right now to how quickly we might be able to achieve any of that is in public interest and what the government wants to do and all of that. And so we're trying to get the government to be a little bit more excited about civil aviation. And so a good way to look at it might be your 8-hour flight to New York. From New York to London might actually become less than a 3-hour flight, and so that's super exciting. And if you could do that at the same price, at the same cost as you could currently do, you have a winner right there. And those are some of the things we're promising we would be able to achieve with the technology in question.
Wow. I mean, you mentioned that the public interest is one of the huge factors. What about as far as the aviation industry? Is this something that they want to seek?
So the biggest factor right now in aviation is cost over comfort, and so if you're able to offer seats for $10 less, people wouldn't care about spending an extra 20 minutes. And so if we are able to bring the cost, I think from a technology perspective, if we're able to bring the cost to where customers can afford it, and you have that kind of performance, it wouldn't be a question of whether people actually are looking for that or want it. It'll be a question of this is better and it's cheaper and it's awesome and we want to do it. So that's basically what I think those are some of the most critical factors right now.
So many different factors that you're balancing all into this one, one thing, and so many different functions that you can have out of this system that you're developing. So where are you right now, I guess, and where do you see it in, say, the next 5 years?
So the stated objective for the company is to commercialize our systems. And so one of the ways we've looked to do that is to file for and get. So we have patents and patents pending, and that gives us some competitive advantage. It allows for us, because we're a smaller company, to collaborate with bigger companies without as much fear or worry as we might have. And so the objective for us is we learn from the progress and the work that SpaceX and Blue Origin and some of these other guys have done, and we are able to speed up that development process. And so I wouldn't be too optimistic if I said in 4 to 5 years we might actually see extremely routine access to space at the cost of what a commercial jetliner might actually cost. The trip from here to say New York might cost you for you to pay a visit to, or at least the transit fees to pay a visit to a space station orbiting the planet.
That is so cool and so fascinating. I want to thank you so much for being here
Sure,
on the
absolutely.
show, too. I want for everybody out there who wants to know more information about your company, where can they go?
So they can go to our website, airbreathing.space. Air breathing is the name because we're developing air breathing systems. And then, yeah, feel free. We do have a form. Fill out the form. Send us an email. And you could reach us on social media. I think we do have a Twitter and we do have Twitter, so you can reach us out on Twitter. So, but yeah, the website is basically our main point of contact. So, yeah.
Great. Well, Othniel, thank you.
Absolutely.
Again,
Thanks
so
for having
much.
me.
Yeah, I appreciate it. And